Good evening, everyone. Good evening, good evening, good evening. I welcome you all again to the JEE Enthuse. Hope all of you are doing great, having the good time. Well, people, if I'm audible and visible to everyone, hit the chat box with the thumbs up. Let me know if I'm audible and visible to everyone. Hi, Navneet. Hi, Srilata. Hi, Khushi. Hi, Hemant. Hi, Janvi. Hi, Ankit. What's up? How are you guys doing? How are you guys doing? That's great, Navneet. That's great. That's great. That's great. Hi, Saurav. Welcome, welcome, welcome. Hi, Roja RK. Hi, Saurav. Wonderful. So, people, are you super duper excited for the session? Let me know in the chat box if you are super duper excited for the session. Yes. Yes, if you are super duper excited for the today's Menti session, let me know in the chat box with the thumbs ups fast. Yes, Ankit, correct, absolutely, absolutely. Yes. Good evening, Sudruti, good evening. Hi, Anisha. Hi, Gulab Singh. Hi, Ubar. Hi, Jitesh. Hi, Rohit. Welcome to the session, guys. Hi, Jitesh. Hi, Raga. Yes, it's 9 o'clock. It's time for you to show the bullseye. Yes. Absolutely, Anisha. Absolutely, I enjoyed the snowfall. Yes, absolutely. Absolutely. Hi, Darshana. Welcome, Darshana. Welcome. Welcome, Akash. Welcome. Hi, Zaim. Hello, how are you? A lot of new people are coming. Yes. Hi, Bathini. Hi, Rohit. Hi, Vijay. Hi, Harshani. Welcome, guys. The DM Kids YT. Welcome to the session. Okay, Akash is new to the channel. Welcome, Akash. Welcome. Hi, Nishant. Hi, Ubar. Wonderful, guys. Wonderful. Walaikum salam, Ubar. Hi, Matthew, bro. What's up? Hi, Sneha. Good evening. Welcome you all again to the JEE Enthuse, guys. Yes. Wonderful. So, people, let's get started with the today's Menti session, which is on electrochemistry. Yes, I'm sure you guys are going to kill it, right? Without wasting a lot of time, let me directly move on. Well, people, in order to participate in this quiz, you guys are supposed to go to www.menti.com, and in that menti.com, just use the code as 6368684. Okay, if you want to participate in this Menti quiz, you guys are going to go on to the www.menti.com, use the code as 6368684. Yes, to log in. Do it fast, guys. Do it fast. I'm waiting for you. A lot of hearts are coming up. A lot of people are joining in. Yes. Wonderful, guys. Wonderful. Go to the www.menti.com and use the code as 6368684 in order to participate in the today's quiz. Yeah? Do it fast. Akash, I'm from extreme north, bro. I'm from extreme north. Do it fast, guys. Do it fast. And let me tell you, you guys are not supposed to type the answer in the chat box, okay? And if you are going to do that, if you will be typing the answers in the chat box, you'll be blocked at that time only, okay? So it's better to go to www.menti.com and type the code as 6368684 to log in, then participate in the quiz. I want everyone to go there fast and join in fast so that we can start the session, guys. Yes? Jatin is super excited for the session. Wonderful. Khushi has already joined. Jitesh has joined. Wonderful. Priyanka has joined. Ridev has also joined. Wonderful. Abdul Hadi is there. Wonderful. Which is the next chapter? Next chapter after thermodynamics is going to be your equilibrium, guys. Yes, the most awaited chapter. Yeah. Well, a lot of people are joining in. People, go to the www.menti.com and type the code as 6368684 to log in. Yes. Do it fast. I'm waiting for you. A lot of people have already joined in, okay? And a lot of people are joining in at the same time. I want everyone to join in fast so that we can start the session without wasting a lot of the time. Yes. Janvi is saying pink hearts are mine. Wonderful, Janvi. Thank you. Thank you for the pink hearts. Yes. Ubar has joined. Navneet has joined. Yes. Jatin, I'm doing wonderful. How are you doing? Yes, Sudruti, I'll be doing the Menti on thermodynamics also. Yes, I'll be doing that. Yes. Saurav is saying Josh is high. That's wonderful, Saurav. Let me see your place in the leaderboard today. Yeah. Mohammad Yasir is here. A lot of new people are coming to the session, guys. Yes, Zaim, I'm in Srinagar. Yes, absolutely. Welcome, Zaim. Welcome, Zaim. Welcome. I'm again telling you guys, go to the www.menti.com and type the code as 6368684 to log in. Yes? Do it fast, do it fast, do it fast. Good evening, Aditya. Good evening, good evening, good evening. Josh is super, sir. That's wonderful, Jatin. That's wonderful. Hello, Wahid. Welcome, welcome, welcome. Go to the menti.com, type the code as 6368684 in order to participate in the today's quiz session. Yes, I want everyone to go through it fast. I want everyone to join in fast so that we can start this amazing session, guys. Yes, I can see a lot of hearts are coming up. That's wonderful. That means you guys are super duper excited for the session. That's actually wonderful, yeah? Exactly, Matthew. I'm going to put this story on my Instagram, okay? I'm going to put the story of the winner on my Instagram. Okay, it's my promise. I'll do that. I'll do that. I'll do that. Definitely, okay? So not a lot of new people are joining in. A lot of new people are joining in. That's great. Yes, Khushi, we are going to kill the session. Absolutely, absolutely. People go to the www.menti.com, type the code as 6368684 to log in the session. Yes. Yes, if you want to participate in the today's quiz session, go to www.menti.com, type the code as 6368684 to log in, and then only you can participate in the today's session, yeah? All right, all right. A lot of people have already joined in. I am going to start the session, guys. I am going to start the session. Akash, there will be around 15 questions, yes? All right. All right. Okay. Okay, wonderful, guys. So let me start then. Let me start. I can see a lot of pictures, guys. Wonderful. That looks amazing, yeah? It actually looks amazing. It actually looks amazing. Wonderful. I'm starting the countdown, guys. Let's move on to the first question, guys. Let's move on to the first question, which is on your screen. Have a look on the question, guys. Have a look on the question. The cell reaction H2 gas plus Cu dye positive aqueous gives twice H positive aqueous plus Cu solid is correctly represented by. Just look at your screen. You have got 4 options on your screen. Just look at it. Look at it. You have got 4 options on your screen, guys. Okay, you have got 30 more seconds to solve the question. You have got 30 more seconds to solve the question. It's a very, very simple question. Janvi is saying it's done. That's wonderful. That's wonderful. You have got 20 more seconds to solve the question. Give it a try properly. Yes. Give it a try properly, guys. Give it a try properly. You have got 10 more seconds to solve it. It's a very simple question. I've taught you all this in detail in the electrochemistry, yeah? Aditya is saying it's done. Khushi is saying it's done. And at the same time, your time is up. Yes, the time is up. The time is up. The time is up. The correct option is the option number A, guys. The correct option is the option number A. Let's see how this option comes over here. See, guys, first of all, let me write the oxidation state of every element right here in the reaction. This is the net cell reaction which I have. Let me write the oxidation state on the top of every element. Over here, hydrogen is in its elemental state, native state, its oxidation state is 0. Right here, copper is in +2 oxygen state. Right here, we have got +1 charge on this hydrogen. Over here, there is no charge, so oxidation state is 0. Yes. Now, people, can I simply say the oxidation state of hydrogen is changing from 0 to +1? That means there will be increase in the oxidation state of hydrogen. Yes. Copper is changing its oxidation state from +2 to 0. That means there is decrease in the oxidation state of copper. Yes, and as you all must be knowing, increase in the oxidation state is what we call as oxidation. Decrease in the oxidation state is what we call as reduction, right? So over here, this H2 is undergoing oxidation, and this Cu dye positive is undergoing reduction. And as you all must be knowing, at anode always oxidation takes place and at cathode always reduction takes place. So how will I be representing this cell? If you remember the standard notation, first of all, I'll put 2 lines in between which represents your salt bridge. On the left hand side of the salt bridge, we always write anode. On the right hand side of the salt bridge, we always write cathode, right? And at anode always oxidation takes place and your H2 is getting converted to H positive. So first of all, I'm going to write it like this. H2 gas, this is H positive aqueous right? This is H positive aqueous. This is my anode right here. And what about my cathode? At cathode, we know reduction takes place and the oxidation state is changing from +2 to 0. So I'll be writing it like this: Cu di positive aqueous, and over here I'm writing Cu solid, right? Is this a complete cell representation? No way. Over here on the left hand side, I have used the gaseous electrode. So I'm going to keep this platinum solid over here. This will be the correct representation of the cell whose net cell reaction is this one. Yes, absolutely. Okay. So which option is the correct one? This is the correct option, guys. This is the correct option, right? So let's check the leaderboard, guys. Let me see the leaderboard. Let me see who is at the top. Let me see who is at the top, who has marked the question properly and fastly. Okay. We have got Sonam at the top, who is the fastest. Wonderful. Then we have got Vijay. Then we have got Carrie, Rohit, Krishna, Sneha, Wolfmeister. Then we have got Devil. Then we have got Arun. Then we have got Ronald. Wonderful, guys. Great job done. Yes. Okay, I'm moving on to the next question, guys. I am moving on to the next question, which is going to be on your screen in 3, 2, 1, and now. Okay, this is the next question, guys. This is the next question. Very simple question again it is. Very simple question again it is. You are given with a cell and you have to write the net cell reaction of it. Yes, a very simple question. I want every one of you to give it a try. You have got 45 seconds to do it. You have got 45 seconds to do it. I want every one of you to give it a try and tap the answers on your screen. Yes, I want everyone to give it a try. Yes, Suraj, you are not going to give the answer in the chat box, bro. You have to go to the menti.com and use the code. Then only you can join in the session. Otherwise, you cannot see yourself in the leaderboard. Yeah. You have got 10 more seconds, guys. 10 more seconds to give it a try. It's a very simple question. It's a very simple question. And all these simple questions, we have killed it in electrochemistry. Just go through the playlist, watch the videos, you'll get to know, yeah? And people, so not a lot of people have marked it correctly. Anyways, let me show you how this question is done. It's a very simple question. Yes, it's a very simple question. First of all, these two lines, it represents your salt bridge. On the left-hand side of the salt bridge, we always write the anode. On the right-hand side of the salt bridge, we always write the cathode. Yes, absolutely. Okay, so first of all, this is my anode and this is my cathode. Yes, this is my anode and this is my cathode right here. First of all, I'll be writing the reaction which will be taking place at anode, and we know at anode oxidation takes place, right? At anode oxidation is taking place. Tin is getting converted to Sn+4. Yes, Sn is getting converted to Sn+4. So the reaction at anode will be Sn solid. It gives Sn+4 aqueous, and at the same time it will give 4 electrons. Yes. Similarly, I'm going to write the reaction at cathode. Absolutely. I can write the reaction at cathode at the same time. Yes. And we know at cathode what happens? Reduction takes place. Over here the oxidation state of chlorine is 0. Over here it is -1. Yes. 0, -1, right? So what should be the reaction? The reaction must be like this: Cl2 gas plus 2 electrons, Cl2 gas plus 2 electrons should give twice Cl negative, right? This will be the reaction at cathode. Now people, in order to write the net cell reaction, can I directly add these two reactions? I cannot directly add these two reactions. Why? Because the electrons are not balanced on both the sides. So I'm going to multiply the second reaction by 2 so that the electron gets balanced, and after that I'll be adding the reactions. After adding the reactions, what am I going to get? I'm going to get Sn solid plus 2 times Cl2 gas. Yes, this is 2 times Cl2 gas. It gives Sn+4 aqueous, and at the same time this is going to be 4 times Cl negative aqueous, right? This is my net cell reaction which will be happening in the cell which was given to me. Yes, and which option satisfies it? You can take it out. This is the one which is satisfying the answer. Yeah, it's a very simple question it was, right? So let me show you the leaderboard of this question, guys. Let's see who is at the top. Let's see who is at the top now. Has the positions interchanged or the positions are still same? No, the positions are going to interchange. Yeah, wonderful. Sneha is at the top. Then we have got Brandy Broken. Wonderful. Then we have got Arun. Kanak is the fastest to answer this. Wonderful. Then we have got Pankaj, we have got Srilata, we have got Randa, we have got Sonam, we have got Vijay, we have got Carrie. Wonderful, guys. Great. Great, great. Oh, Srilata is from class 10th and she's on the leaderboard. Yeah, that is wonderful. That's actually great. That's actually great. That's actually great. Let's move on to the third question, guys. Let's move on to the third question. Let me see if you can solve it or not. A very, very simple question. It's going to be again. Yes. Which among the following is a strong oxidizing agent? Very, very simple question. Strong oxidizing agent. Oxidizing agent is the one which oxidizes others and itself undergoes reduction. Yes. And itself undergoes reduction. You have got 30 seconds, guys. You have got 30 seconds to give it a try. Janvi saying it's done. Wonderful, Janvi. I want every one of you to give it a try. Yes. Which one of the following the strong oxidizing agent? Oxidizing agent is the one which oxidizes others, itself undergoes reduction. Yes. So you have to compare the reduction potentials over here. That's it. That's it. You just have to compare the reduction potentials of these electrodes, which are in the options. The time is up. The time is up. Let me see how many of you have marked it correctly. Okay. Not a lot of people have given the correct answers. Let me show you how this question is done. Okay. The first option, guys, it was E naught of. E naught of A changed to A positive. A solid changed to A positive. This value is given to me as 1.1 volts. Yes. Similarly, the second option which we have, this is E naught of B changed to B negative. B solid changed to B negative. This value is given as 3.1 volts, right? The third option which is given to me as E naught of C positive changed to C solid. Okay, this value is given to me as 4.1 volts. And the last option, guys, you can check it out. The last option, that is E naught of D solid changed to D positive. This value is given as 6.1 volts, right? And we are supposed to identify which one among these electrodes is the strong oxidizing agent. Yes, we have got element A, element B, element C, element D. We have to check which one among the following is the strong oxidizing agent. First of all, oxidizing agent is the one which oxidizes others, itself undergoes reduction. So first of all, I'm going to compare the reduction potentials of all. Yes. Let me show you guys. Is this the standard oxidation potential of A or this is the standard reduction potential of A? How do we identify that? Over here, there is no charge on A. Over here, charge is +1. So from 0 to +1, charge is increasing. Oxidation state is increasing. And increase in the oxidation state is what we call as oxidation. So this potential is the standard oxidation potential of A. Right? Similarly, this is 0 to -1. 0 to -1 decrease in oxidation state. That means it is SRP. Yes, it is standard reduction potential of B. Similarly, +1 to 0. +1 to 0. Again, it is reduction potential. That means this is the standard reduction potential which we have. 0 to +1. 0 to +1. It is again what? It is the standard oxidation potential, right? First of all, I'm going to convert this standard oxidation potential into standard reduction potential, and at the same time, I'm going to convert this standard oxidation potential into the standard reduction potential. Yes, very, very simple. So I can write standard reduction potential of the first one is going to be simply as -1.1 volts. Standard reduction potential of the last one is going to be -6.1 volts. Yes. Now people, compare the standard reduction potential values of all these elements right here. The one which will be having the maximum standard reduction potential will easily undergo reduction, and that will be acting as the better oxidizing agent. So C has got the maximum value. C has got the maximum value of SRP, standard reduction potential. So C will undergo reduction easily. I mean C positive will undergo reduction easily. So it's going to be the better oxidizing agent right here. So this one is the correct one. Wonderful, guys. Great job done. Okay, let's check the leaderboard then. Let's check the leaderboard. Let me see who is at the top now. Let's see. Okay, Hadi is going to come up. Hadi is going to come up. Yes, Hadi. Wonderful. Matthew is going to come up. Hadi is the fastest. Okay, Hadi has moved to the first place. Then we have got Matthew, we have got Sneha, we have got Kushi, we have got Aditya, we have got Arun, we have got Kanak, we have got Pankaj, Srilata, Randa. Wonderful, guys. Great job done. Great job done. Hadi has moved to the first position and is the fastest to answer this one. Wonderful, guys. Wonderful. Okay. I'm moving on to the next question then. Let me see if you can solve this or not. I'm starting the countdown in 3, 2, 1, and now. And now. And now. Yes. Yes. Which of the following statement is not correct about an inert electrode in a cell? Inert electrode in a cell. It does not participate in the cell reaction. It provides surface either for oxidation or for reduction. It provides surface for conduction of electrons. It provides surface for the redox reaction. Which of the following statement is not correct? Read the question carefully. It is not correct, right? Which of the following statement is not correct about the inert electrode in a cell? Aditya is saying it's done. Aditya is saying it's done. Nadeem, you're not supposed to write the answer here, bro. Go to thementi.com, go to thementi.com, use the code there, and then you can participate in the quiz. Yes. 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 The time is almost up. Yes, the guys. Yes, the time is up. Yes, the time is up. Yes, the time is up. Okay. Very less percentage of students have marked it correctly, guys. First of all, we were supposed to check the incorrect statement. We were supposed to check the incorrect statement. The first statement was, inert electrode, it does not participate in the net cell reaction, which is true. It does not participate. Second, it provides the surface either for oxidation or for reduction. Absolutely, it's true, right? It provides surface for conduction of electrons. Absolutely, it is true. And the last one, guys, it provides surface for redox reaction, which is not possible. Yes, very, very simple question it was. Very, very simple question, right? Let's check the leaderboard now. Let's see who is at the top. Sonam is going to come up. Aditya is going to come up. Devil is going to come up. Krishna is going to come up. Yes, 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 yes. Okay, Aditya is at the top now. Wonderful, Aditya. Sonam was the fastest to answer. Then Hadi has moved to the third place. Krishna has come up. Matthew has come up. Wonderful. Then we have got Devil. We have got Sneha, Kushi, Arun, Kanak. Wonderful, guys. Great job done. Let's move on to the next question then. Let's move on to the next question. Let me see if you can solve it or not. This is the question number 5 among the 15 questions which we have in the session, right? I'm starting the countdown in 3, 2, 1, and now. The countdown has started, guys. The countdown has started. The countdown has started. Okay, let's see what the question is. For which of the following reactions Mg di positive plus 2 electrons gives Mg? Okay, its E naught value is given. Fe tri positive plus 3 electrons gives Fe solid. Its E naught value is given. Choose the strongest reducing agent. Reducing agent is the one which reduces others and itself undergoes oxidation. Yes. Reducing agent is the one which reduces others and itself undergoes oxidation. Right? Right? Very, very, very simple question it was. You have got 18 more seconds to solve the question, guys. Give it a try fast. Give it a try fast. Kushi is saying it's done. Rafia is saying it's done. Amateur Buddhist is saying, sir, when you'll start organic for class 12? Soon, bro. Stay tuned, stay tuned. Yes, the time is up. The time is up. It's a very simple question, guys. I've shown you the question. This is the question which I've actually shown you in the classroom. Yeah, you can go to the playlist. You can watch the second session of electrochemistry. In that second session, I have showed you this question there. Yes. Okay. So 9 people have given the correct answer. The correct answer is going to be the magnesium, which will be the strongest reducing agent among the two, right? Let's check the leaderboard, guys. Let's check the leaderboard. Let's check the leaderboard. Let me see who's at the top now. How these again going to come up? Yes, absolutely. Matthew is going to come up. Wonderful. Okay, Hadi's at the top. At the second place, we have got Matthew. Then we have got Arun. We have got Aditya. We have got Srilata. Srilata was the fastest to solve the equation. Wonderful, Srilata. Then we have got Sodam, Rohit, Krishna, Devil. Then we have got Sneha. Wonderful, guys. You guys are truly doing a great and wonderful job at the same time. Yeah? I'm moving on to the next question. Let me see if you can solve this or not. Let me see who is going to come as on the leaderboard. The question, guys, very simple. In the electrolytic cell it is flow of electrons is from. This is not the electrochemical cell. It is the electrolytic cell, if you remember. Yes, we have discussed this as well. In detail, we have discussed it, guys. In detail, we have discussed it. Yes. Yes, you have got 20 seconds. You have got 20 seconds to give it a try. Sakshi is saying it's done. Kushi is saying it's done. Rafia is saying it's done. Aditya is saying it's done. Ankit is saying he's in class 11th. Wonderful, Ankit. Saurav is saying it's done. Jitesh is saying it's done. Tanish is also done with it. Ankit got the 11th rank. Okay, wonderful. The time is up, guys. The time is up. The time is up. Supraja is done. Ardik is also done with the question. Yes. Okay, very less percentage of students have marked it correctly. Guys, it was not the electrochemical cell. It was not the electrochemical cell. And it was not your galvanic cell. It was not your galvanic cell, I mean. In the galvanic cell, if you remember, the flow of electron was from anode to cathode. The moment of electron, the direction of electron was from anode to cathode in your galvanic cell. But it was your electrolytic cell, where it is opposite. Yes, the direction of electron is from cathode to anode through the internal supply. This we have discussed in detail in the electrolytic cell. Yes. Very simple question it was. Very simple question it was. Let's check the leaderboard. Let's check the leaderboard. Let's check the leaderboard. Matthew is going to come at the top. Okay, at the second place. Aditya is going to be there, I guess. Yeah. Okay, Matthew at the top. Aditya at the second place. Hadi has moved down to the third place. Then we have got Devil with the fastest to answer this question. We have got Arun, Srilata, Sonam, Rohit, Krishna, Sneha. Wonderful, guys. Great job done. Great job done. Let me move on to one more question then. Let me move on to one more question. I'm starting the countdown in 3, 2, 1 and now the countdown has started. Okay. Let's see if you can solve this or not. Find the correct value of oxidation potential for the given half cell whose SRP value is also given. Half cell is also given. Fe solid gives FeSO4 whose concentration is 0.1 molar and you are given with the standard reduction potential of iron electrode right here. You have got exactly 1 minute to give it a try and let me know the answer, guys. Let me know the answer. Let me know the answer fast. 50 more seconds. It's a very simple question, guys. Trust me on that. Yes. Yes. Saurav is saying the question is done. That's wonderful, Saurav. Sonam is also saying the question is done. Okay. Great job. Great job. Ankit is still on the 11th rank. It's okay, Ankit. Give your best. Give your best. Okay, you have got 10 more seconds to solve the question, guys. 10 more seconds. Now Navneet is saying it's done. Rohit is saying it's done. Yes. 3, 2, 1. The time is up. The time is up. The time is up. Okay. Majority of the students have given the correct answer. Wonderful, guys. Great job done. Let me first of all show you how this question is solved. Let me first of all show you how this question is solved. What are we supposed to calculate? We are supposed to calculate the oxidation potential for the electrode which is given to us. Yeah, this is my electrode. Okay. If we are supposed to calculate the oxidation potential, then this electrode has to act like the anode, and at anode what happens? Oxidation takes place, right? So oxidation state over here is 0. Over here the oxidation state of iron is +2. So what should be the reaction? First of all, Fe solid changes to Fe di positive. Yes, Fe di positive plus how many electrons? +2 electrons. Either you can write over here as FeSO4 or you can write the Fe di positive. Choice is all yours. Yes, it's very simple. Okay. So how many electrons are being exchanged right here is the value of N, if you remember. Yes. Can I write the expression for QC, reaction quotient? Absolutely, I can do that, which is going to be concentration of Fe di positive. This is going to be the value of QC right here. And what is the concentration of Fe di positive? Concentration of Fe di positive is going to be same as that of concentration of FeSO4, which is 0.1. That means 10 power minus 1. Yes. At the same time, E naught of Fe solid changes to Fe di positive, which is the standard oxidation potential of iron. Is it given to me? No. I'm given with the standard reduction potential of iron, which is minus 0.44. So I just have to take the opposite sign. It becomes 0.44 volts. Yes. Now people, I can simply use the Nernst equation. Okay. I can simply write oxidation potential of iron, which is E of Fe solid changed to Fe di positive is equal to E naught of oxidation E naught of Fe solid changed to Fe dye positive minus 0.0591 divided by N, and it's going to be log of QC, and QC value you know. Guys, everything you have, we have to calculate this value, right? This is something which we have to calculate. We got the value of standard oxidation potential, right? We know the value of N, right? We know the value of QC. Everything you have, you just have to put the values into the equation. You'll get the value of oxidation potential of this iron electrode, right? And the value exactly you'll be getting as 0.47 volts, which was the correct one. I'm sure, right? I've shown you all these type of patterns, all these types of questions during the lectures, right? When I taught you the Nernst equation, I taught you its applications, right? Okay, and the first application of Nernst equation was to calculate the oxidation potential of the half cell, right? Which is, this question is based on the same concept, if you remember, yeah? Wonderful. Let's check the leaderboard now. Let's check the leaderboard now. Let me see who is going to come to the top now. I think Hadi is going to move the first position now. Again, is that? No. Aditya is still at the first position. Wonderful, Aditya. Then we have got Matthew. Then we have got Hadi. We have got Arun. We have got Devil. We have got Krishna. Kushi. Kushi has come on the leaderboard. Wonderful, Kushi. Then we have got Vijay. We have got Srilata. We have got Ankit. Ankit was the fastest to answer this question. Wonderful, Ankit. Now, Ankit, you have come to the leaderboard. Welcome to the leaderboard, Ankit. Welcome, welcome, welcome. Yes. Wonderful. Let me move on to one more question then. Let me see if you can solve this or not. This is the 8th question. I'm going to start the countdown in 3, 2, 1, and now. I am starting the countdown. Yes. Yes. Standard electrode potential of 3 metals X, Y, and Z are this respectively. The reducing power of these metals will be. Standard electrode potential of these metals are given. That means you are given with SRP values of 3 metals X, Y, and Z. We have to check the reducing power. We have to check the reducing power. Okay? Very, very simple question. I've shown you the same question, guys, during the sessions as well. You can go to the session number 4, lecture number 4 of the electrochemistry. There you can find the same question which I showed you there. Okay? You have got 10 more seconds to give it a try. I want every one of you to do it. The different world is asking, sir, what about chemical bonding? Chemical bonding will be started soon, bro. You just stay tuned. Yes? Yes? Wonderful, guys. Majority of the students have given the correct answer. Exactly. Reducing power of Z is going to be X. It's going to be greater than Y. Okay. I've shown you the same question in the 4th session, 4th lecture of the electrochemistry. You can go to the playlist. You can watch the session number 4 in which all these types of questions are solved there. Yes. And all the concepts related to these questions are discussed there in detail. Okay. Moving on, and let's check the leaderboard now. 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 It's going to be a great competition, guys. Hadi is the fastest to answer this question. Aditya is still at the top. 2nd place, we have got Hadi. We have got Arun at the 3rd place. Then we have got Devil. Matthew has come down. Krishna has come down. Kushi has come up. Okay, Vijay is there. Sneha is there. Kati is there. Kati is the new to the leaderboard. Welcome, welcome, welcome. Yes. Okay. Okay, I am moving on. Let me move on to the 9th question, guys. Let me see if you can do it or not. Thank you. I am starting the countdown in 3, 2, 1, and now. The countdown has started, guys. The countdown has started. What will be the EMF of the following cell? You are given with a complete cell, guys. You just have to calculate the EMF of this cell, right? You have got exactly 1 minute to solve this question from now on. Okay? Okay, give it a try fast. Ankit is saying question is done. Oh my God. Ankit, you are doing it quickly. Okay? That's great. I want all of you to give it a try fast. You have got still 40 seconds to give it a try. Yes, you have got 40 seconds. You have got 40 seconds. Rafia is saying it's done. Okay. What about the rest of the people? Sakshi is saying it's done. Wonderful, Sakshi. Then we have got Munib is saying it's done. Ankit is saying, sir, I practice to answer fast. That's wonderful, Ankit. That's wonderful. Kushi is saying it's done. Media TV is saying 0.772 seconds to answer. That's wonderful. Okay. No one is saying it's done. Rohit thinks his answer is correct. Ishwar is saying hi to Sakshi. Okay, the time is up, guys. The time is up. The time is up. The time is up. Okay, very less percentage of students are marked it correctly. Oh my God. Welcome, Abdullah. Welcome. See, guys, how this question was to be solved. It was a very simple question. I've shown you all these type of patterns of the questions during the sessions, if you remember. Yeah. Now let me tell you how this question is solved. It's a very simple question. Yeah. You are given with a cell in which tin solid gets converted to SN dye positive, right? Concentration is 1 molar. In the middle, you have got the salt bridge. On the right hand side of the salt bridge, you have got Pb dye positive, concentration 10 power minus 3 molar. It gets converted to Pb solid. And you are given with the standard reduction potential of tin, and at the same time, you are given with the standard reduction potential value of the lead. Right? Now, people, the first thing which I'll be doing right here, I'll be writing the reaction taking place at anode. At anode, the reaction which takes place. Have a look, guys. On the left-hand side of the salt bridge, we always write anode. So at anode, your tin solid is getting converted to SN dye positive, and at the same time, tin solid gets converted to SN dye positive aqueous, and it gives 2 electrons. Yes, this is the reaction which takes place at anode. Now, what about cathode? At cathode, reduction takes place, okay, and your Pb dye positive is getting converted to Pb solid. What would be the reaction then? I would say Pb dye positive aqueous plus 2 electrons. It's getting converted to what? It's getting converted to Pb solid. Electrons are balanced on both the sides. I'm going to write the net reaction, which is going to be tin solid plus Pb dye positive aqueous. It gives what? It gives SN dye positive aqueous plus Pb solid. Yes. Now, people, how many electrons have been cancelled right here? How many electrons have been exchanged? 2 moles of electrons have been exchanged in the net cell reaction. So N value is 2. Yes. What about the expression for QC? It's simply going to be concentration of SN dye positive divided by concentration of Pb dye positive, if you remember. Yes. Concentration of Pb dye positive. We are given with the concentration of SN dye positive as well as Pb dye positive. Concentration of SN dye positive is given to me as 1 molar, okay, divided by concentration of Pb dye positive is also given to me as 10 to the power minus 3 molar. Yes, so QC value you are getting as 10 power 3. Now, people, only one thing is left, that is E naught cell. E naught cell is equal to E naught of cathode minus E naught of anode, and I'll be taking SRP values for both cathode and anode. Now, people, my anode is the tin, okay, and what is the SRP value of tin? This is the SRP value of tin, which is minus 0.14 minus SRP of anode. SRP of anode, your lead is the anode. Yes, is that? Wait, guys, just a second. Your cathode is which one? Your cathode is lead. So I'm going to write the SRP value of lead first. SRP value of lead is minus 0.13 minus SRP value of anode. Anode is your tin. So SRP value of tin is minus 0.14. Yes, from here you'll be getting the E naught cell. Now, simple, you'll be using the Nernst equation and you'll be getting the answer. Yes, and as per Nernst equation, E cell is equal to E naught cell. E naught cell value you have got, right? E naught cell value you have got from here. Okay, E naught cell you are done with minus 0.0591 divided by N value you have got. Yes, N value you have got log of QC. QC value you have got. Just you have to solve this equation. You are given, you got this value, you got this value, you got this value, all the values you have. So you'll be getting the E cell from here as minus 0.078 volts. It was a very simple question, guys. Yes, so go through the sessions again. Anyone who is having any sort of problem in solving these questions, go to the lecture number 4 of the electrochemistry. There you'll be finding these types of questions in detail. Yes, very simple. Okay. All right, guys. All right. So let's check the leaderboard. Let me see who is at the top now. Rafia is going to come up. Khushi is going to come up. Okay, wonderful, guys, wonderful. Let's check the positions. Okay, Rafia was the fastest to answer. Khushi has moved to the 3rd place, and Rafia has come to the 2nd last place. Wonderful, guys. Aditya is still at the top. Hadi is still at the 2nd place. Khushi is still at the 3rd place. Okay. Arun is at the 4th. Then we have got Devil, we have got Matthew, we have got Krishna, we have got Vijay, we have got Rafia and Sneha at the end. Yes, Rafia, you're on the leaderboard. Welcome, Rafia. Welcome on the leaderboard. Welcome to the leaderboard. Yes, I'm moving on to the next question, guys. Let me see if you can solve this or not. Let me see. For the cell, zinc solid changed to Zn di positive, whose concentration is C2. Zn di positive aqueous, whose concentration is C1, changed to Zn solid. Choose the incorrect statement. Guys, you have to choose the incorrect statement. Okay? Incorrect statement you have to choose right here. Okay? Incorrect statement you have to choose right here. Yes. Yes. Very, very simple question. It's a concentration cell, guys, and I have taught you the concentration cells in detail. Yes. Yes, Ankit is enjoying the Menti session. That's wonderful, Ankit. Yashish is saying it's done. Yes, Abdullah, it's the 10th question already, bro. You are late. Yes. Okay, 3, 2, 1. The time is up. The time is up. Let me see how many of you, okay, very, very less percentage of students have given the correct answer. People, if you remember, this is your electrolytic concentration cell. Yes, this is your electrolytic concentration cell. Now, we were supposed to check the incorrect statement, right? For the electrolytic concentration cell to be spontaneous, concentration of electrolyte in cathode, that is C1, must be greater than the concentration of electrolyte in anode. Then only this electrolytic concentration cell is going to be spontaneous. Yes, this was something which we have discussed during the sessions. Yeah. Now, people, check the options. The cell reaction will be spontaneous if C1 will be greater than C2. This is correct. If C1 will be greater than C2, cell reaction will be spontaneous. If C2 is greater than C1, current will flow from cathode to anode. No way, no way. If C2 is greater than C1, will it normally act like the galvanic cell? Will there be the movement of electrons from anode to cathode? No. Will there be any current from cathode to anode? No way, no way. This is the incorrect one, guys. This is the incorrect one, right? This is the incorrect one. Check the third option. If C1 is greater than C2, if C1 is greater than C2, then cell will be spontaneous. Current will be flowing from cathode to anode. This is correct. Yes, absolutely. And if C1 will be equal to C2, this cell is not going to work, right? The cell will be at equilibrium. Yes, very, very, very simple, right? Okay. Let's check the leaderboard now. Let's check the leaderboard now. Let me see who's at the top now. Let me see who is at the top now. Okay. Rinda is the fastest to answer this question. Aditya is still at the top. At the second place, we have got Hadi. Third place, we have got Kushi. Then we have got Arun, Devil, Matthew, Krishna, Rinda, Vijay, and Rafia. Wonderful, guys. Great job done. Great job done, guys. Great job done. It was a simple question if you remember the concepts. Yes, I am moving on to the next question. Let me see if you can solve this or not. I'm going to start the countdown in 3, 2, 1, and now. The countdown has started, guys. I want every one of you to give it a try. Yes, this is the question. In the electrochemical reaction, I mean this, increasing. Okay. Very simple question it is, guys. Very simple question. Increasing the concentration of Fe di positive increases the EMF of the cell, increase the current flow, decrease the EMF of the cell, alters the pH of the reaction. What do you think is the correct one? What do you think is the correct one? Give it a try properly. Aditya is saying it's done. Yashish is saying KGF part 2. Okay, Yashish, okay. Yes, Senthil, I'm in Srinagar. Yes. Welcome, Ankit, welcome. Dayasankar, no, NCERT is not just enough for JEE Advanced, bro. Yes, Saurav, exactly. Matthew is confused. Matthew is confused. Aryan is saying it's done. That's wonderful. You have got 3 more seconds. The time is up. The time is up. Majority of the students have marked it correctly, guys. That's a wonderful news. See, it was a very, very simple question. Yeah? See, guys, first of all, if I want to write the QC expression for this reaction, QC expression, reaction quotient. I'll be starting from the products. This is Zn di positive, this is Fe di positive. So I'm going to write concentration of Zn di positive multiplied by concentration of Fe di positive to the power stoichiometric coefficient, that is 2, divided by concentration of Fe tri positive, concentration of Fe tri positive ka square, and this zinc is in solid state right here. Yes, so its active mass is 1, right? And what about the Nernst equation, guys? What about the Nernst equation? Nernst equation is E cell is equal to E naught cell minus 0.0591 divided by N, and this is going to be log of QC. Log of QC. Now, what happens to the EMF of the cell on increasing the concentration of Fe di positive? What do you think? On increasing the concentration of Fe di positive, I would say QC value will increase. If QC value increases, right, this whole term will what? This whole term will decrease. That means EMF of the cell will decrease, which was a very simple question. Yes. Okay. Let's check the leaderboard, guys. Let's check the leaderboard. Let's check the leaderboard. Let me see who is at the top now. Let's see who is at the top. We have got Aditya at the top and the second place. Wait. Let's check. Okay, the list has changed, guys. Aditya is at the top. Then we have got Devil, we have got Arun, we have got Matthew. Arun has moved to the third place. Wonderful. Devil has moved to the second one. Wonderful. Matthew, fourth one. Wonderful. Adi has come down. Khushi has come up. Krishna is there. Rafia is there. Vijay is there. And Sri Lata was the fastest to answer this question. That's actually wonderful and a great news. Okay. Yes. Yes. That's great, Rohit. That's great. That's great. Okay, guys, I'm moving on to the next question. Let me see if you can solve that or not. This is the 12th question of the today's Menti session. I'm going to start the countdown in 3, 2, 1, and now. The countdown has started. The countdown has started. Let me see if you can solve this or not. The electric charge for electrode deposition of 1 gram equivalent of the substance is very simple question, guys. Very simple question. We have solved these questions, these types of questions in detail, right? Yes. You just have to, if you do not remember, you just have to go to the playlist of the electrochemistry, right? In your playlist, you will find the electrochemistry chapter, and in the last 3 sessions, we have completely discussed the electrolysis part in detail, where we have talked about these questions in detail. Yes, it is a very simple question. Okay. Yadav, you have to go to the menti.com and you have to use the code there, then you can join the session. Yeah. We have got majority of the students who have marked it correctly, guys. That's actually great. We have discussed these sort of questions in detail. So the electric charge for the electrode deposition of 1 gram equivalent of a substance is going to be 96500 coulombs per second, which we already know. We have discussed in detail. Yeah. Okay. I'm moving on. Let me show you the leaderboard first. Let's see who is going to come at the top now. Let's check. Hadi was the fastest to answer. Aditya is still at the first position. Hadi at the second one. Khushi is at the third. Krishna is at the fourth. Khushi has moved up to the third position. Wonderful, Khushi. Then we have got Arun. We have got Devil, Matthew, Kati, Vijay, and Sukhda. Wonderful. Sukhda is on the leaderboard. This is the first time Sukhda is on the leaderboard. Wonderful, Sukhda. Keep it up. Great job done. Yes. I'm moving on to the next question, guys. Let me see if you can solve that or not. This is the 13th question. I'm going to start the countdown in 3, 2, 1, and now. I have started the countdown. Yes. I have started the countdown. Yes. A solution of CuSO4 is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at cathode? Very simple question, guys. You have got exactly 1 minute to solve this question. We have solved these type of questions if you have watched the videos of electrochemistry. Yeah, we have solved these type of questions in detail. Okay. Still you have got 35 seconds, guys. Still you have got 35 seconds. I want every one of you to give it a try. Yes. Yes. Dayasankar, bro, there are different big books to be followed for physical, inorganic, and organic. Okay, go to the Shimon sir's video. Okay, go to the playlist. You can find a video which Wassim Sir took about the books which are to be consulted for the mains and advanced. There you can check it out, which all books are to be followed for physics, chemistry and mathematics, right? Matthew is saying it's done. Khushi is saying it's done. Okay, we have got majority of the people who have marked it correctly. That's actually great. It is a very, very, very simple question. Yes, it is a very, very, very simple question, guys. First of all, for the copper to get deposited, at the cathode, the reaction which has to proceed, the reaction which has to occur, that should be Cu positive plus 2 electrons changed to copper solid. Yes, and this copper solid will get deposited on the cathode. Okay, this is the reaction which will be taking place at the cathode right here. Okay, very, very, very simple question. First of all, if I'll ask you what is the N factor of this copper solid, how do we calculate N factor? I would say N factor of this copper is going to be number of electrons exchanged during the reaction, which is 2, divided by stoichiometric coefficient of copper, that is 1. So this 2 is the N factor of copper right here. And what were we supposed to calculate? We were supposed to calculate the mass of copper deposited. So I'll be using the Faraday's first law. Yes, I'll be using the Faraday's first law. I'll write the mass of copper deposited in grams will be equivalent mass of copper multiplied by I multiplied by T divided by 96500. Yes, equivalent mass of copper is going to be molar mass of copper. Let me change the color, guys, just a second. It's going to be molar mass of copper multiplied by current multiplied by time divided by N factor of copper multiplied by 96500. Just look at the equation, guys. You have got all the values here. Molar mass of copper, as you all must be knowing, that is 63.5. Yes, grams per mole. The value of current is given to us. Yes, the value of current is given to us, that is 1.5 amperes. Time period is given to us as 10 minutes. I'll be converting these 10 minutes into seconds. N factor of copper, you know, this 96500 is the constant. By putting all the values in this equation, you'll be getting the mass of copper deposited, and its exact value will come as 0.296 grams. So 0.296 grams of copper will get deposited during this electrolysis right here. Okay? Yes. Hi, Hardik. Okay. Wonderful. Garina is saying in Free Fire. Okay. All right, guys. Let's check the leaderboard. Let me see who's at the top now. It was a very, very simple question, guys. Aditya is not going to change his place. Okay, we have got Aditya at the top, Hadi at the second position, then we have got Krishna, we have got Devil, we have got Khushi, we have got Matthew, we have got Arun, we have got Vijay, we have got Rafia, and Sri Lata was the fastest to answer this question. Wonderful, guys, wonderful, great job done. Yes, Hadi, maybe, maybe, bro. Okay, I am moving on to the next question. I'm starting the countdown in 3, 2, 1, and now the countdown has started, guys. Yes. Calculate how much current is required to produce H2 gas at the rate of 1 ml per second under STP. Reaction is given to us. Okay, very, very simple question it is. Very simple question. Calculate how much current is required to produce H2 gas at the rate of 1 ml per second under STP. And you are given with a reaction at the same time. Yes. That's wonderful, Sam. That's wonderful. Aditya is saying it's done. Okay, Rafia is saying it's done. Naveed, you cannot answer the question here, bro. Naveed, you cannot answer the question here. You have to go to the menti.com. Then only you can participate in the quiz. Okay? Okay, wonderful. All right, you have got 10 seconds, guys. You have got 10 seconds. Yes, you have got 10 seconds. 3, 2, 1. The time is up. It was a very, very simple question. Yeah? Majority of the students have marked it correctly. Wonderful, guys. Wonderful. So first of all, what is given in the question? 1 ml of H2 has to be liberated in 1 second. So volume of H2 that should get liberated over here is 1 ml. In how much time? It should get liberated in 1 second under STP. Yes. First of all, the reaction is given to me. The reaction is given to me. Twice H positive plus 2 electrons, it changed to H2 gas. Okay. People, first of all, can you tell me the N factor of H2 right here? N factor of H2 right here is going to be equal to number of electrons exchanged during the reaction. Number of electrons exchanged during the reaction, that is 2, divided by stoichiometric coefficient, that is 1. Very, very, very simple. Yeah. Okay. Now people, volume of H2 which should get liberated is 1 ml. Can I write the number of moles of H2 which must get liberated will be equal to 1 divided by 22400. These many moles of H2 should get liberated in 1 second. For that, how much current is required? So I'm going to use the formula as per the Faraday's first law, right? Number of moles of H2 liberated will be equal to I multiplied by T divided by N factor of H2 multiplied by 96500. Yes, this I value we are supposed to calculate. T time is given to us. N factor of H2 we have calculated, right? Number of moles is given to us. I just have to equate these two. Yes, I'll be getting the value of I from here, and the value of I you'll be getting as 8.61 amperes. Yes, so 8.61 amperes is the current which is required in order to liberate 1 ml of H2 in 1 second at STP. I'm sure this is clear to everyone. I am moving on to the next question, but before showing the next question, guys, let me show you the leaderboard. Yes. Let's check the leaderboard. Okay, majority of the students have marked it correctly. Matthew has changed his place. Wonderful. Aditya is still at the top. Then we have got Hadi at the second position. We have got Krishna. We have got Devil. We have got Matthew. Matthew is the fastest to answer. We have got Rafia. We have got Arun. We have got Vijay, Kushi, and Sukhda. Wonderful, guys. Great job done. Yes, wonderful, guys. Okay, I am moving on to the last question, guys. This is the last question which is going to decide the overall rank of yours, okay? And whosoever is going to come on the leaderboard, that is going to be my Instagram story for 2 days, okay? Yes, who will top the session, yeah? Okay. I am going to start the countdown. This is the last question. Guys, I'm telling you, whosoever is going to be at the top of the leaderboard after the question, that name is going to be my Instagram story, Shimon Sir's Instagram story, Shreya Sir's Instagram story for minimum of 2 days. Yeah? Okay, I'm moving on. 3, 2, 1, and now the countdown has started. The value of electrode potential for this at 298 would be very simple question. The value of electrode potential, okay, and you are given with the hydrogen electrode at 298 Kelvin will be very simple question. I have shown you this question. When I taught you the Nernst equation for the half cells. Yes, you just have to use that concept and do the question. Yes. 30 more seconds. Rafia is saying it's done. The value of electrode potential. So basically you're supposed to calculate the reduction potential of this hydrogen electrode right here, whose concentration is given, whose pressure is given, right? Temperature, everything is given. Yes. Very simple question, guys. We are supposed to calculate the reduction potential of the hydrogen electrode right here, and the time is up. Let me see how many of you have marked it correctly. Okay, a lot of people, majority of the people have not marked it correctly. Yeah? Okay, before showing you the leaderboard, guys, let me show you how this question was to be solved. Yeah? We are given with a half cell. Yes? This is my half cell, this is my hydrogen electrode. For this hydrogen electrode, we are supposed to calculate its reduction potential. So first of all, this electrode has to behave as the cathode, and if it behaves as the cathode, so reduction should take place. So the reaction should be twice H positive aqueous plus 2 electrons should get converted to H2 gas. This is the reaction which has to take place, right? So first of all, I got the value of N from here. This is the value of N. Yes. Now let me write the QC expression. It's going to be equal partial pressure of H2, which is given as 1 atm, divided by concentration of H positive, which is 10 to the power minus 4. This is 10 to the power minus 4 raised power 2. Raised power 2. So QC value is going to come as 10 power 8. Very, very, very simple. Yeah? Yes? Yes, guys. So you got the QC value. You got the QC value, you got the N value. As you all must be knowing, the standard reduction potential, the standard reduction potential of hydrogen electrode, the standard reduction potential of hydrogen electrode is taken as 0. Yes. Now I'll be simply using the Nernst equation. Yes. I'll be simply using the Nernst equation, and as per your Nernst equation, I'll be writing the reduction potential of hydrogen electrode, which is represented as E of H positive change to H2 will be equal to E naught of H positive change to H2 minus 0.0591 divided by N, and it's going to be log of QC. I have got everything right here. I have got everything right here. I have got this value, it is 0, standard reduction potential of hydrogen electrode. I got the value of N, which is 2. I got the QC value. When you will put all the values into this equation, you are going to get this value, which represents the reduction potential of the half cell of the electrode, which was given to me, and the answer which you will be getting from here, it will be minus 0.236 volts. Yes. So let's check the leaderboard, guys. Let's check the leaderboard. Let's check the leaderboard. Let's check the leaderboard. Yes. Let's check the leaderboard. This is the leaderboard, guys. This is the leaderboard. This is the leaderboard. Okay. Wait. Let's see who is at the top. We have got Aditya at the top. Great, Aditya. Great. Wonderful. Let me take a picture of it, guys. I'm taking a picture of it. As I told you earlier, this is going to be my story for 2 days. Yeah? Wonderful, Aditya. Great job done. So, at the first position, we had Aditya. Second position, we have Hadi. Then we have got Rafia. Then we have got Krishna. Then we have got Devil. Then we have got Matthew, Arun, Vijay, Khushi, and Saurav. Saurav has come to the leaderboard. Wonderful, Saurav. Great job done. And Aditya, congratulations, bro. Congratulations. You have done actually a wonderful job, a great job. I hope you guys have loved the today's session. On every Sunday at 9 p.m. I'll be coming with the Menti session, guys. So do not miss these sessions at all. And let me tell you, tomorrow we are going to do the session on entropy. Okay. And after that, we'll be doing the Gibbs free energy. And after that, we are going to start the new chapter, which will be the equilibrium, guys. Okay. The most awaited chapter. Okay, so congratulations, Aditya, once again. So people, if you have not liked the video yet, if you have not shared it or subscribed to the channel, do that right now, because we want to reach every part of the country so that everyone will get benefit out of these sessions. Okay, so do that and good luck. See you guys tomorrow at 5:30. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.